Hello guys, welcome back to the tutorial. So in this tutorial we are going to talk about encryption. Starting ahead with the encryption, we first need to know what is a cryptography. So cryptography is the art and science of making a crypto system that can provide information security. It deals with the actual securing of the digital data which we send across networks and all. So what basically happens in a cryptography is that if this is the sender and this is the receiver, if it as we have seen in the previous tutorials, if we are sending directly plain information via in the URL like a query parameter or in any form which is not encrypted, so what happens if there is an intercept in between the sender and the receiver? It can read the data, and not in only just can read, it can also manipulate the data. So in either case, there can be a serious damage to the information with the help of information or anything. So that is where the need to crypt the input arises. So what happens here is that if this is the plain text, this is my information which I want to convey to the receiver, I apply some kind of encryption algorithm over on this one with the help of encryption key. So when the plain text and the encryption key combines, we get a cipher text. So this cipher text is something which is generally not readable or understandable by a human or any interceptor or by a computer or digitally or anything else. So in this way, no one can understand what I'm trying to send to the receiver. And on the receiving end, the receiver basically knows. I'm sorry. So the receiver basically knows what kind of algorithm was used to encrypt the input text, and he uses the same algorithm to decrypt it and get the data back. So that was kind of the overview of how the encryption in a crypto system happens. So what exactly is an encryption? Encryption is changing the input data in a way so that it is unreadable by humans, or not just by humans. Even if there is a digital interceptor in between, it is not understandable by that also, that what kind of information is being conveyed. Uh, Now encryption, it can be bring back to the original format where this encryption. This is where the concept of key comes into. If a key is used by the sender to encrypt the data, the same key or even a different key which are mathematically related can be used to decrypt the data into the same input format. So that is about the whole encryption and decryption. Now, there are certain types of encryption. Basically, it can be categorized broadly into two types. The first one being the symmetrical key encryption, and the second one being the asymmetrical key encryption. Now, the symmetric key encryption, the encryption process is where the same keys are used for encrypting and for decrypting the information. As I have just said that the sender can use the same key and the receiver can use the same key to encrypt and decrypt the information correspondingly. While in asymmetric key, what happens is that different keys are used for encrypting the data, while a certain key, which is kind of mathematically related to the encrypting key, is used to decrypt the data. Now, inside the symmetrical key encryption, there are two broad types. The first one being the block ciphers, and the other one being the stream ciphers. So, when I say block ciphers, what basically I mean in this scheme, the plain binary text is processed in blocks or groups of bits at a time. That is, a block of plain text bits is selected. A series of operations is performed on this block to generate a block of cipher text bits. What I mean it is, if suppose we have an input text of a1 2 3 4 5 6 7 8, so and my block cipher algorithm is designed in a way to process 4 bits at a time. So it will pick out 1 2 3 4, then it will pick out 5 4 6 7 8. Sorry, 1 2 3 4 and 5 6 7 8. So we have this 4-bit block. Now the operations, all the operations which will help in in encrypting my input will be performed on this one block. We have got like two blocks, 1 2 3 4 and 5 6 7 8. So the operation will be performed on these blocks, and we will get the output cipher result or encrypted result, and then encrypted result will be combined together and sent across. And in the similar way, they are decrypted also. So this was about the block ciphers. So in stream ciphers, stream is cipher is nothing else, but instead of using blocks, the operation of encryption is performed on a single bit. So it is technically nothing but a block cipher of size 1. Instead of having a block of 1, 2, 3, 4, what I did, I performed all my operations of encryption on a single bit, that is 1, then on 2, then on 3, then on 4, then 5, 6, 7, 8, just like that. And the result is combined and sent across. So as you can see here, blocks are how block ciphers work. If we have 1, 2, 3, 4, 5, 6, 7, 8 input data, we select a block of 1, 2, 3, 4 of 4 bits, pass it into our encryption algorithm, and the encryption key is imposed on that plain text. And with the help of that, we get a block of ciphertext which is sent across. Now, there is a concept of padding in block cipher. So the reason being, what happens when a block cipher process blocks of fixed sizes, say 64 bits. The length of the plain text is mostly not in a multiple of block size, right? If you are sending some data, we cannot be sure that okay, the size of this data has to be in the multiple of the algorithm, the encryption algorithm we are using. So for example, if we have 150-bit plain text, it will provide two blocks of 64 bit, and there will be a third block of 22 bits. Now this last block of bits need to be padded with some redundant information or redundant bits, so that the length of the final block is equal to the block size of the scheme. The block size of a scheme is 64, so we need to pad 42 bits, 42 redundant bits. Redundant is like the keyword here, because whatever bits we are adding, it should not change the text. It should only pad the block so that the application, so that the algorithm can be applied on the input. That is it. So this is what the padding is all about. So there are multiple different kinds of padding. While getting into coding, we will briefly touch upon those things. So now, block cipher schemes. So we are mainly going to talk about the block ciphers only, not the stream ciphers here. And in block ciphers also, we'll take a deeper look into the advanced encryption standard while coding. So there are basically, as you can see, there are three types of, not just three, there are many types of cipher schemes, but we are brushing upon these three major ones. The first one being digital encryption standard. So this was a very popular block cipher in the late 90s or the early 90s, but now it is considered to be as broken block cipher due to mainly because of its very small key size. After that came the triple DES. It is kind of a variant of a scheme of DES application only, but it is it is kind of still used, but it is inefficient compared to the new faster block ciphers available. So the third one, this advanced encryption standard is relatively new block cipher based on encryption algorithm Rindell. So that won the AES design competition also, by the way. So this is the latest one, and is very popular at sale. So far what you've seen is that the encryption is of two types: the symmetric and the symmetric one. Symmetric, we have the stream ciphers and the block ciphers. The block ciphers, there are DES, triple DES, and AES, and this AES is what we are gonna basically focus on. So in block cipher encryption, what we have certain blocks to cipher or to encrypt, and there are certain modes of operation. These modes are nothing but the rules for a generic block cipher. What happens is that how the blocks are processed is greatly results in the encryption, how well the encryption will work. So this basically, there are two types of modes in block cipher. The first one being electronic code book, which is called the ECB mode, and the second one being cipher block cleaning mode, which is the CBC. So in EBC, what happens, if you see the diagram over here, it's pretty simple, it's pretty straightforward. The user takes the first block of plain text and encrypts it with the key to produce the first block of ciphertext. This is our plain text, whatever input we are giving to the algorithm. This is the key, this is the algorithm, they both combine and we got our ciphertext. So if we have input of 1, 2, 3, 4 and the block size is 4, then 1, 2, 3, 4 goes in here, then 5, 6, 7 it goes in here, 9, 10, 12, 11, 12 goes in here. So block of 4 are being worked upon separately with the help of key, and the ciphertext is resulted. The same way the decryption happens here. Now The problem here is that the ECB mode is pretty deterministic. That if the plain text block given to the algorithm, it will be encrypted again and again, resulting in the same output. So if we have plain text as 1 2 3 4, and suppose our key is uh, say 2, so when we apply our key and on the plain text, we will always get the same output. If we have 1 2 3 4 here, then again we have 1 2 3 4 here, we will the ciphertext will always be the same. So in this way, what is happening is that there is a duplication of the code, right? The ciphertext is duplicated, so this might help the hacker in understanding what kind of pattern is being followed in the input itself. So this is kind of a drawback of ECB mode. So moving on to the CBC mode, the cipher blockchain. Uh, this is pretty cool actually. The problem of determinism is actually solved here. This makes the whole encryption a lot non-deterministic. So the image is pretty unflashy here. So what is actually happening here? We got the plain text. Now what we do here, we use something called initialization vector also. In initialization vector here, uh, as the name automatically suggests, that it is used to initialize the complete encryption process. We have the plain text here. On the plain text, we XOR the n bit of our IV on it. This IV is nothing but a key itself, but it is only used once in the initial stage of the encryption. We store the IV and plain text, and after whatever the result is there, that result we send into our algorithm, encryption algorithm, and the key is applied into on top of that, and we get the ciphertext. So what is happening if we have a block size of 4, 1 2 3 4 acts as a plain text, we send the IV, some result came, suppose a X, then the key is applied on X, and we get the ciphertext. Now what is happening on the second block of our plain text, which is 5678, the key will not directly be applied, and neither will the IV, because as we have said that initialization vector is nothing but a key which is used only once in the initial stage. It cannot be used again and again. So what do we use here? So that is where the ciphertext come in. What we do is that instead of using IV here, we use the ciphertext from the previous block. So this is the ciphertext we got from the previous block. We are using it on the next block, plain text, and again zoring these two, zoring the ciphertext and the plain text, we got the result. Now we are applying the key on that result into our algorithm, and we again got the ciphertext, and the same process goes on. This will be zored with the next block, we got something, key applied, and we got the ciphertext. So the good thing about here is that if we have an input called 1 2 3 4 here, and 1 2 3 4 here also, the output of these two will be totally different. Reason being, we are applying, or we are zoring IV with this one, but we are not zoring IV with this 1 2 3 4. Instead we are zoring some other output with this 1 2 3 4. So that is when the complete output will be different. So just to understand how it might work, a little example if we'll take here. Suppose in the ECP mode, if we talk about initially, we have say 5, and we have an input of 1 2 3 4 and 5 6 7 8. So suppose then our algorithm is designed in such a way that the key is multiplied to the input. In this case, our ciphertext, or our say, sorry, cryptotext will become 5, then 10, 15, 20. This is for the first block. So the in blockchain, what is happening, the complete algorithm is applied on one block, then on the second block. So first this block will be generated 5101520, then key will be applied or the multiplied to the second block, so it will become 25, 30, 35, 40. So this is the cipher, this is the complete ciphertext right up till here. So this was uh, ECB, electronic code book. So the problem here is that if we again have something called 1 2 3 4 right over here in our output, what we will get again is 5101520. So as you see, this one and this one is particularly same. So if the hacker got in touch with even if with the encrypted data, he will be able to understand, okay, so whatever the data is in the input, these blocks are probably the same. So that is kind of the disadvantage